Alright, so let's say you're given this diagram of a mass with initial velocity on a spring. And the question says a mass of 1 kilogram is attached to a spring with K constant 20 newtons per meter. Initially, the spring is unstretched and a mass is moving at 1.5 meters per second to the right. Find the maximum distance the mass will move to the right. We can start off by drawing a free body diagram for the mass. We have our mass here. We're going to have the weight force, the normal force, and we're going to have the force due to the mass being connected to the spring, pulling it to the left. Apply our general work equation here. We know that f of x is equal to kx for the spring force. Plug that in, and if we compute the integral, we get this for the work. So this is going to represent the work that the mass will apply on the spring during its motion. If we assume that x1 equals 0, this is like the origin position for the mass. We can plug that in for x1, and we just get this. So this is the work that the mass does on the spring during the motion. From the point x0, the origin point, to this unknown x2 position, the work that the mass is going to apply on the spring from it being at an initial velocity given by the equation we just solved for here. And this also means that the work that the spring is going to apply to the mass is opposite, so it's going to be equal to negative 1/2 kx squared. You can use this to write a work equation for the spring to find the final distance of the mass. And so if we start with the other work equation, which is work equal to the change in kinetic energy, we write it in this form here where k equals 1/2 mv squared is the general kinetic energy equation. And we also apply what we just found for the work of the spring, and we know that v2 is going to be equal to 0 because at the maximum distance the velocity of the mass is going to be 0 because it stops moving. Plug these values into the expression. We isolate for x2 by multiplying both sides by 1/k and then taking the square root of both sides. We end up getting this expression here for the final position x2, and then we can plug in our known values from the question, compute the amplitudes in the units in the square root, and plug that back in, and then we can take the square root of that, computing the amplitudes in the units, and then we can plug that in, multiply to get the final answer. And I just want to note that this is the final distance for the mass, and notice our units make sense. The units are in meters, and that makes sense for a position. So that means that our equation to solve for the position was correct. If we look at our diagram here, we have our initial position here, we have our k constant, we have our initial velocity for the mass equal to 1.5 meters per second, final velocity is equal to 0. We know that x2 we just found is equal to 0.33 meters, so the total change in displacement from that initial velocity is 0.33 meters. One thing to note, after the max distance, the spring will pull the mass back in. So at this point, Fs, the spring force is actually at a maximum.